Okay, let's get started. Want to mention that John Scruggs used to work at not Barclays, BlackRock. Will be in my coming to my class tomorrow, 237 class, and he's going to be addressing some portfolio investment issues. But he also worked in the area of pairs trading. Remember the example that we went through, Royal Dutch and Shell? Those examples are discussed in one of his papers. So if you want to come, you should be able to talk to him about that. I think his time is quite limited, he said, but he'll be in the classroom, so you can use the time to talk to him. Okay. And the second item is that I think I gave feedback to almost every proposal that have come on the project, except for two of them, which I will take care today. And I think most of the project proposals are good, except some of them I did not get a sense where exactly you are going. So maybe as you start working on the project, and if you have any questions, it's just let me know. I think it's also, I'm not going to look for, definitely the results or anything like that, but I'm looking for ideas that you have tried and how they worked, how they didn't work. And even if some of the ideas that you have proposed in the write-up, they don't work out, that's fine too. But as long as you can show the work, that's good. Okay. So John Scruggs will be here tomorrow. If anyone wants to come and attend the other class, 237 class, and as he have mentioned, since he has done work in pairs trading, you can also ask him questions in that area. Okay. Before I get started, any questions, anything that you should want me to answer? Okay. So you should be finishing your assignments now. I think if there are any questions, send it to us. We'll try to clarify if any questions are there. Okay. And today I think, I still have to complete this web analytics, how this information can affect stock price movements. That's the idea here. And the idea of using sentiment scores to predict what's going to happen in the future has been around for quite some time. And if you are familiar with the so-called Consumer Confidence Index, so the Consumer Confidence Index is supposed to measure whether people are going to invest in big ticket items such as durables, such as cars and washers, dryers, and all those big ticket items. So they are not going to invest unless they are confident about the future of the economy. So essentially they ask for that, their sentiment, and then come up with an index and then try to project how the economy is going to do in the future. Okay. So that is the idea behind this sentiment scores, and seeing how, there the interest was mostly relating sentiment scores to macroeconomic events. Here I think we are going to more focus on sentiment scores related to mostly financial side. Okay. Financial returns. So I think, if you look at Keynes, I think he mentions that markets fluctuates due to investors' animal spirits. So there's always going to be noise traders. And if you look at the finance literature, they really have decomposed the market into two groups. One is the informed traders, the other one is the noise traders. So the idea, I think, is that informed traders get the information first and they trade, then eventually the information gets to all the noise traders. By the time it reaches the noise traders, I think the information gets dissipated. That's the idea behind it. So if the information comes, obviously there is going to be mispricing and excess volatility. People who don't have correct information, they don't know what the right price of the stock should be, and they may not be willing to trade, even if the informed traders are willing to trade. So there's lots of things that could go on. Okay. So the way I think I'm going to set this up is that there is one or two important papers or an important piece of work that I left out in the write-up that I have here. I think this is sort of the second time I'm incorporating these ideas into the lecture. So I think I still have a lot more work to do as far as this part of the course is concerned. Okay. So I think I want to briefly mention that there are a set of papers by Paul Tetlock. I think you should read those papers because those are probably quite interesting set of papers. This is Paul Tetlock. I think the paper that I am going to briefly go through today is 2010, came in Review of Financial Studies, RFS. Okay. So the way he sets it up is the following. It says period here, period 0. Everyone sets up their positions. And then between 0 and period 1, so informed traders observe the signals. Observe the signal, and they trade based on that. And then between period 1 and period 2, the information slowly leaks out, and this becomes a public news. So in period 2, we have public news reveals the signal. And then I think public also trades based on this. So the idea between these two is that informed traders are trading based on information. They are also trading for liquidity reasons, right? So once the information based trading gets exhausted for liquidity, they are also competing with period 2 people who are mostly noise traders. And then finally you will see that this all settled down in period 3. So that's how they set up. Okay, that is the basic setup they have. Okay. So I think you should look at Tetlock's papers. I think most of the papers were written based on newspaper stories. I think some of these things are taken from Wall Street Journal stories. They actually went to the actual stories and coded the information as positive information, positive sentiment versus negative sentiment, and they went through exhaustive data collection based on just the newspaper information. Okay, these are the hypotheses that they come up with. The first one is the following. The first one is, so I'm going to write that between period 1 and period 2, they call it as return 2. Period 2 and period 3 they call it as return 3. Okay. So essentially this says that regression coefficient of post news returns in this case, post news returns are supposed to be R3 on news events written which is given by R2 increases with the informativeness of the news. As you know that not all news are equal, so they have some way of coding that information in terms of how newsworthy that information is. So this was the first hypothesis. This is the first finding. The second finding is that expected trading volume in period 2 expected trading volume in T2 increases with the newsworthiness of the event with Vs. Okay. Remember, I think we talked about this before. We said that there is a close association between, volume and information, right? This is what they test it out. Okay. I think I mentioned that sometimes volume is taken to be also influenced by information. It's not just a proxy, it's also should be treated as endogenous variable. Okay. And then the 3 is that correlation between volume and the absolute return, which is given by R2. So how do you interpret absolute return? It could be treated as a volatility, right? Can go both sides, positive and negative, could be a substitute for volatility. So correlation between volume and volatility increases with the informativeness of the news with Vs. That is the third thing. And the fourth one, a concept that we have not covered yet, but I'll briefly mention what it means. Something we are going to cover into the, it may not be today, but certainly on Wednesday, I will go through that, the concept of price impact. Price impact is that impact of your trade on the prices, on the future prices, right? That's the price impact. So price impact is generally tends to be higher if you are a major player, that way you influence the price. It's also going to be higher if the volatility of the stock is higher. So many other factors that go in here. So this is a little bit surprising finding. It is that price impact in the news event period decreases with the news informativeness. Okay. So the idea here is that generally I think they trade based upon the news. Once it reaches the public information, you can see that people with informed traders have to trade mostly for liquidity because information is available to everyone. They are going to make the decisions on their way. Okay? So those are the main findings. I want you to look at this paper. Unfortunately, I didn't have chance to put it in here, and having reviewed the notes over the weekend, I thought this should be also included here. Okay? So there are two prominent concepts we are going to see. One is sentiment contains market-wide impact, and there are also impediments to short selling, because you will see that people who don't have the information, they want to hold on to the stocks and they may not put it in the market. So even if the informed traders have information that they want to capitalize, there may not be enough liquidity into the market. So if there is no short selling, there may be rational short selling rational. So traders cannot exploit overpricing. Okay, it's possible that people who don't have enough information, they may not want to sell it. That's the idea behind it. Okay. So in practice, how does one measure sentiment? Okay. So we could see that this is a sort of an evolution that took place, and this was actually some of the first papers that came out, and then the papers based on the newspaper events came out. I think the first set of papers wanted to measure sentiment. So what they did was they looked at these five or six factors here. The first one they looked at was the closed-end fund, okay, the performance of the closed-end fund discount. And the second one is the New York Stock Exchange turnover. So turnover sort of gives you the market activity, right? So if there is less activity, that means that people are not confident in the economy, in the financial market. And they also looked at number and average of first day returns on IPOs. IPOs are the initial offerings, right? So that shows how much confidence people have in the new ventures. There is one other thing that I left out here. There should be 6 of them: closed-end fund discount, New York Stock Exchange turnover, number of IPOs that issued, and the average of the first day returns on IPOs. There is also one other thing, just you may want to add this here. This is sort of a equity share in new issues. All these things are related to new issues. Okay. And the last account is that dividend premium here. Okay. So they compute these 6 scores, and then they look at the first principal component of that 6 scores. And you can see the plot of that is given in the next page. That is the plot. So they took the data from 1970 to 2006 or 2006, and then they compute this, get these 6 scores, and then compute the principal component, and they plot it over time. Okay. So you can see that there is a lot of variation in this component, right? And you will expect it because principal components are derived based on the assumption that it captures the most variance in the data, so you should expect that. But the key part of this is that they took this graph and matched with a number of anomalies that occur in practice. Okay? So the variation in this graph is supposed to be matched with variation in market-related activities. That was the main idea behind this paper. Okay? So before I forget here, I think those are the main things that I wanted to say. Okay? So they also did one other thing. They took the 6 scores that I mentioned and they regressed it on macroeconomic factors, the overall macroeconomic factors, just to make sure that these don't reflect just the macroeconomic factors. They remove that one, then try to see if there's any association between this and the market-wide financial characteristics. Okay? So they sort of identify this, relate that sentiment score, which is the first principal component of the score, to 11 noted anomalies. Okay? 1 and 2 is supposed to be financial distress, and 3 and 4 is supposed to be composite stock equity issues. 5 is the total activities, I think. Then 6, net operating assets. 7 is momentum. So they go through all these things, and they show that anomalies are stronger after you see the high sentiment scores. Okay? So if you look at these scores here, I think you'll see that at some point they peak and some points they go low. So whenever they peak, after the peak, they show that there is a connection between that and those 11 anomalies that they mentioned here. Stop. I think as far as our class is concerned, I think the key fact is that there seems to be a connection between momentum that we covered in the class and the sentiment scores. Okay? Anomalies are stronger following high sentiments. Okay? So you can see that this is where it started. It started with using macroeconomic factors, the financial factors, such as what are the 6 factors we saw here. Those are the 6 factors. Using that factors, come up with one index that can capture the overall sentiment, and then they relate that to other information that I mentioned here. Okay? So this is the first set of papers. The second one is based upon Tetlock's work, where they look at how the newspaper-based information can be related. Then came this Da et al. In Journal of Finance. This is another paper you should take a look at. They also have an earlier paper based upon Google search volume index. How is it connected to stock market performance here? Okay. So here what they have done was they looked at roughly 1,200 items, and they're all related to some sort of market information. So they construct change in the search volume index. So that is what the delta quantity is. And then instead of using all 1,200 items, they look at only the first top 30 items. And then they construct what they call fear index. I don't know what they call it, but fear index. So essentially the rank of that quantity based on the changes. They add all those things, top 30 ranked items, and that becomes an index. And they wanted to see if there is any connection between that index and market returns. You can see that the fears index, you can see connected to market returns. There is high correlation with low returns today, high correlation with higher returns tomorrow. That's how it works. It also is related to volatility. It also related to noise trading. Okay. So essentially their main idea is that this whatever index they construct out of is based on Google search volume index. They can show that there is a connection between the two. Okay. And the key part of this is that you'll see that the correlation do not last for too long. They persist only for a couple of days and it's gone. Okay. So many of these studies reveal that generally there is not much information. Okay. So there is also, I think, this original paper by Engel and others that clearly shows that whenever there is information, the news event releases come out, that point you'll see there is high volatility. That's a general finding, but this one is probably much more relevant. It relates the web data to market index. Okay. But today I'm going to talk a little bit about a data set that I had access to. There's a lot of data sets available now. There are 2 or 3 companies that have use this information. If you want to use search volume data, I think you can look at a company called Ravenpack. So take a look at it. I think it's I'm not sure. I think it's associated with NASDAQ. You should take a look at it, Ravenpack. And here what I did was to get some data from a company called iCentium. And the Ravenpack data is mostly web search volume data. The iCentium data is based upon Twitter data. iCentium. Okay. So the Twitter data is supposed to be almost instant. So most of the strategies should be based upon, if you want to monetize it quickly, so you should try to use that one. Okay. So let me briefly show you the data here, and we can talk about the issues related to using this kind of data. Okay. So I'm not sure where exactly it is. So that is the type of data we have. Okay. I don't know how to make this one. Let me briefly go through this and then I can see. So we have this data sync. They started collecting this only starting 2012, and you can see that this is the time of the day the tweets came in, and they use the keyword is QQQ, which refers to NASDAQ, okay, and then this is the sentiment score. This is all processed already, sentiment score. It also gives you the tweet count. This is not important here. This I'm trying to open this one. I'm not able to get this one. This is a Twitter ID, okay. So which means the same person can come tweet, at different times of the day. You can have said different things about this particular stock, particular index. There's also information on whether it's been retweeted or not. And then we have retweeter ID. There is this author ID, okay. Let me see if I could open this one a little bit better. Yeah, that is author ID. You can see that this particular person is constantly tweeting, right? You can see from there. And he's also, if you go down, you'll see that he's also changing his sentiment score every 5 minutes. We don't know what's going on there, okay? And you can also see that there is a financial bio. I think, for somehow they quote some people with or may know a little bit about finance, others who don't know about finance, 1 and 0. There is also a number of followers, how many people follow them, and number of tweets, and then there's some whitelist and all that stuff. So they have that information here. So that is they also have the impact factor, okay. So if you look at this data here, this is almost tweeted, it's in any point in time, okay. And we wanted to see how these tweets are related to market data. So what we did was we looked at ES Mini. ES Mini is not quite same as using NASDAQ prices. So we looked at the ES Mini. So we have this daily data here. So we have open, high, low, close. We also have the volume information. Okay. So our goal was to take that sentiment data and relate that to, daily price data, see if there is any changes that can be traced back to the sentiment data. Okay. So that's the idea here. Okay. So when it comes to Twitter data, I think you should be careful because this we didn't want to meddle with processing of this information. We just took what they've given us, trying to see if there is any connection between this and so this is what we have, okay. So we have this date and timestamp, cumulative number of tweets and all that stuff. So they also suggest 2 strategies, and the strategies are given as follows, okay. Actually they suggest 3 strategies. The first one, they call it as crossover strategy. The crossover strategy is that if the difference between 3-day moving average and 30-day moving average is positive, go long, otherwise go short, okay. So what does that crossover strategy remind you? Moving average. Remember one of the moving average, so that's same as that. And they also have the second strategy which says that open to open, regress open to open returns on 10-day moving average, and also its lag to predict the return. If the return is positive, go long, hold the position until the next day is open. Okay. And the third strategy is a broad market signal. It's same as 1, but for the entire market to cover S&P 500 assets. Okay. The same as 1, except that you're looking at market-wide information. That's the difference. Okay. So I'm going to show you how I did this one. Okay. So I want to relate the sentiment score with return, volume, and volatility, and check if those 2 strategies 1 and 2 work. I didn't have time to check the third one. Want to see that. Okay. So remember the original data for iCentium was given on a point process at any point in time, but I need to relate this back to daily data. So I need to somehow aggregate this information into daily part. So I took the iCentium data and aggregated for each day. Okay. The way I aggregated was that I just took simply the average sentiment score for the day. Okay. And you could do all kinds of fancy things because you can give more weight to the person who is tweeting, who has more number of followers, right? You can do all kinds of things. I just did the simple average, okay? So when you look at this is how the plot looks, okay? So this is supposed to be the sentiment average score, and then you have the number of tweets, and then that is the written, open to open written, and this is the volume data that I have, and that is the volatility data, okay? So given this kind of data here, how do you relate one to other? My main goal is to see if the sentiment score is related to returns, right? That's what matters. Sentiment score, is it related to volume? Sentiment score is related to volatility. So those are my main concerns that I have, okay? So what I did was, this is a simple thing I did, which is nothing but looking at the cross correlation function between sentiment score and the return, okay? So here you can see that this is supposed to be open return. What is open return is you look at opening price today and open price yesterday, calculate the return based on it, and I wanted to see if there is any connection between the sentiment score and the return. So here x of t minus s is supposed to be sentiment score, previous sentiment scores, and y of t is supposed to be today's return. That's how I calculated. You can see that there is some small signal here, and these two numbers are supposed to be significant. There is some here, we didn't know how to interpret it, but this one was pretty useful information for us, okay? So essentially what it says is that if you know previous day's sentiment score, you should be able to say something about the returns today. That's the main idea here, okay? So I also looked at the correlation between returns and also retweet average. Do you see any significance here? No. And you can see this is supposed to be the returns and the number of retweets. I don't see anything happening here. And so this is the overall regression analysis that I thought I briefly should go through. If you look at the first regression there, I included returns as a function of sentiment score average and return average and financial bio, all that information. You can see R squared is pretty low, 2.5%. There are only two variables that are significant, okay? But including the average score on the same day is not that useful. But cross-correlation function was pretty useful information. It told me that if you know what the previous day's sentiment score is, you should be able to say something about the return next day. So as soon as I included the average one, what I mean by that is the lag one variable, R squared shot up to 8.9%. And you can see they're not too bad when it comes to predicting volume. Can you see that? Volume R squared is pretty good. And volatility, I think, in this kind of finance data, I would take whatever R squared I can get. You can see that it's still lag plays a role here. Lag is a negative sentiment. Its volatility is negatively related to average sentiment here. So it sort of tells you that there are signals that you can use at the macro level, okay? So how do you use this for trading? So in order to use this for trading, I want you to go back and see the three strategies here, right? So the first strategy is that if the difference between 3-day moving average and 30-day moving average is positive, go long, otherwise go short. Open to open is the regress open returns, and then based on the 10-day moving average. When I talk about moving average, I mean this is the moving average of the sentiment score, right? It's not using any of the price data, okay? So when I do this here, you can see I do a little bit of simple statistics just to see if these things will work out. So you can see that I divided this into crossover. What is a crossover strategy? If the short-term moving average crosses the long-term moving average, right, 3-day versus 10 days, then we are going to say go long. So when I do this one, you can see this is a negative score and this is a positive score as expected. But the key part of it is how is it related to the return. You can see that during the negative scores, return is minus 0.08, positive score return is positive 0.2268, 22% return. So if the sentiment score is positive, you can see that there is a immediate payoff there. Okay. So it is noted the return on days of signal to enter result in positive term, otherwise negative term. Okay. So I'm going to evaluate this strategy with buy and hold. Essentially what I do here is that when the sentiment score is positive, I'm going to go long. Sentiment score is negative, I'm going to go short. Okay. So when I do this, this is the equity graph that I get, and you can see that the top one is the crossover strategy. The red one is supposed to be buy and hold. Generally, crossover strategy does pretty good, right, based on this information. Okay. So I'm going to test out the second strategy. What is the second strategy? You look at the regression of returns. So open to open strategy is that calls for regressing returns on 10-day moving average and its lag. So when I look at this model here, I didn't see any of the coefficients significant. R squared is 0.6%. It's a poor prediction model, okay, at least for this particular case, prediction model. And the rule says that if the predicted return is positive, enter, otherwise do not enter. Okay. So I did the same type of calculations here. You can see that the scores are, sentiment scores are in the as we expected. But if you look at the returns, is there any big difference between these two? There is no difference at all. Okay. So that clearly told me that this strategy is not going to work out. Okay. So that sort of reflected here. You can see that the top graph is supposed to be buy and hold. There is some overlap here. Afterwards, you can see buy and hold is far better, and the red graph is supposed to be open to open. It's not working out well. Okay. So among the two strategies, crossover strategy seems to work out well, and that was the main conclusion of this. Okay. So how do you use this kind of data in practice? Okay. How do you use this kind of data in practice? So here what I did was to take the daily data and match it with point process data which aggregated to the daily level and then used it. But people are not going to wait for one full day to trade, right? They want to trade immediately. So there are a lot more work to be done. One is how do you relate this to data with much shorter durations? So we are looking at, right now looking at 5-minute data, see how it is connected to the 5-minute data. And the second part of it, which is more important, is that it seems to work well when you're looking at some sort of global index, like NASDAQ is almost a global index. So for macro indices, this kind of sentiments will work. Whether it will work for individual stocks, we don't know about it. So there are a few areas that one should work on this. Okay. So this kind of data, I think now it's available. So this company, I think you have to pay money to get this data. This was just a sample data that I used for the class. Okay. Any questions? Any questions on this? Okay. This seems to be an interesting area people currently are working on, something that you may want to think about. I'm going to start on this so there's a lot of information here. I'm not sure how much of it I'm going to go through in the class, and okay. So the order book data is important to understand, because when you're doing actual buying and selling, what is in front of you is the information from the order book, right? So you need to make a decision based on that. So before I get to it, I have some simple notes that I think that will set it clear. Okay. So, few concepts that I would like you to know here is the following. Okay. So, I think Max was mentioning this very clearly. So, there is a parent order size, parent order. Okay. So, I am going to write this as X units. Okay. So, X is so large you cannot get to the market right away. So, you need to split this X into n child orders. Split X into n child orders. Child orders. Okay. So, let us assume the child orders are of size n1, n2, etc. up to nn, and you want to split it into in the interval 0 to t. 0 to capital T. Okay. Most of this, most of the trading is supposed to start in the morning. They usually wind up in the evening. So, when you talk about 0 to capital T, we are looking at just 1 day interval. Okay. In fact, most of the trading occurs in the almost in the first 2 hours they enter the market. Okay. So, these are the things that we are going to keep in mind, and P0, I'm going to call it as arrival price. Arrival price. So, this is the price that you observe when you get into the market. It could be the opening price or price before or at the start of the first child trade, just the arrival price. Okay. So, we have two quantities that people look at. One is this average executed price. Average executed price, which is given as you look at how much on the average you get for the n child orders that you sent out divided by x. So, this becomes average executed price, P delta. Okay. And there is also volume weighted average price. Volume weighted average price. Okay. What is the volume weighted average price? It's people write it as VWAP. This is for the market level. Okay. Here I think, besides you, so many other people are also trading, and at the end of the day you should be able to calculate what is the overall market price that people paid, Pj star divided by overall volume. So, this is called P tilde VWAP. Okay. I think the question about execution strategies, how good your strategy has been, all depend upon comparing these two with the arrival price or comparison between themselves. Okay. So, you can look at the implementation shortfall as the average difference between that. So the two quantities people look at in practice is that P of x minus P0. So what is the price that you have obtained after, when you enter the P0 was the price. So this sort of tells you, how good your overall strategy was to get into the day. And you can also look at the difference between this and P VWAP. What does this difference tells you? It tells you that whether you entered the market at the right time. Okay, these are things you can see. So there is another concept you are going to see, what we call as market impact. Market impact is going to be price that exists 30 minutes after your last trade ends. Okay, so this would be like after you finish all these trades here. So let's assume that this is the last trade plus 30-minute price. So that is the price that you have minus P of 0, that is the arrival price that you started here, and this is sometimes known as market impact or price impact. Usually they take it as 30 minutes, doesn't have to be. Some people look at much shorter duration. Okay. So the questions that we are going to discuss today is that little later is going to be that two questions here. I think there's lots of questions. The two questions that are important here are that how do you take this x and divide this into number of child orders? So you need to first of all decide how many child orders you need to divide, right? But if you divide it into small number of child orders, that means the size of the order is going to be big. The size of the order is big. When you enter the market, you're likely to drive the price against you. So you have to be careful about it. The second is that once you know the number of child orders, how do you divide this into N1 to Nn? Okay. So I think the question that we will look at soon is that how to divide x into N1 to Nn. So that is a part. Okay. So this is where I think the key papers that we are going to see are going to be the Almgren and Chris paper, which I think was played a very important role in algorithmic trading. Okay. Okay. So once you decide to enter the market, you have to understand how the order book works. Okay. So before I do that, let me briefly talk about it. Okay. So now we think it's all order driven market here. The specialists are pretty much almost gone. It's all order driven market here. As Max was mentioning, there are 11 exchanges now, and BATS I think is part of New York Stock Exchange. BATS or ARC, I don't remember. One of them is part of New York Stock Exchange. So collective behavior of these rational people can be reproduced by modeling non-strategic traders. So there are two things here. How do you model the changes in order book? Okay. As I mentioned before, order book changes very fast. The number of cancellations that occur are pretty large. And how do you model this? Okay. So a couple of papers I think I want you to look at. Okay. These are the stochastic models here. You need to incorporate the information in the current state of the order book, and you also have to look at how the orders arrive, and in view of that you need to decide the optimal order execution and look at how the intraday prices change during the course of the day. Okay. So these are main things that people do in practice. So as far as the order arrival rate is concerned, in order to make the mathematics simpler, they assume that the arrival rates are generally exponential function. because it's easy to model. And if it is exponential function, we also know that the time difference between two arrivals is going to be, if arrivals are Poisson distribution, the arrival time difference between successive arrivals is going to be exponential distribution, which is sort of assuming that there is no memory between the successive arrivals. But all these things come so fast, it's very difficult to model them quickly. So I think there are some approximate methods people have come up with. Okay, so just briefly, I think so the order book. What is an order book? As I mentioned before, order book is nothing but intent to buy or intent to sell, and how many units you want to buy, how many units you want to sell. Okay, so that's the idea behind it. And so the things that are of interest is the following. If the new orders come, how does it affect the price? And if the price changes, what is the probability of executing a limit order? And what is the probability of making the spread? Making the spread means that sending a market order so that you can cross the spread and buy or sell. Okay, so there are three important quantities. I think before I do that, so there are few decisions you have to make. Okay, first of all, I think you need to decide a limit versus market order. Right? That's the important thing. And if you are going to go for a limit order, okay, what position you want to go? You want to go at the top of the book or bottom of the book, right? Okay, so position. Now I think with the in both cases, whether it's a limit order or market order, now it's also additional complexity. That is that you have so many exchanges, right? To which exchange you want to send your market. Okay, so exchanges. Exchange. Okay. So this is a it's a very old example here. So you have this ask and bid here, and you can see that the number of shares they want to sell is 28, and that's the price they have. And then this is the number of ask is that 2, and then you have 69,500, and prices are usually quoted by whatever price times 100. So that's how we have it here. And then your limit buy order comes, buy 2 at 69,200. You can see that changes the composition of the book. Okay, and the second is that this is a market sell order comes of 10. I think market sell order is going to give you whatever the best price that you have, right? So it removes that quantity, and then that's how it changes here. Okay, with the multiple exchanges that we have now, there is this rule called Regenemus. Okay. So the main idea here is that if you send a market order, you are supposed to get the best of all exchanges, best price of all exchanges. Okay, so that sort of guarantees that it doesn't matter if you are going to send a market order, you can send it to any exchange, you get the price. Okay, but you also have to be careful, I think, and there's a rebate structure that we talked about. So that rebate structure can influence the changes. Okay, so here the cancellation of 3 sell orders, and you can see whenever it cancels, it removes the order from there, and then takes it out here. Okay, so these are all simple things, but you can see that it's not going to go in the slow motion. It changes so fast. It's a very fast moving system. Okay, so this is the level 1 representation of this. So when we talk about level 1, we essentially look at the top 2 positions on both sides. So the difference between these two is called bid or spread. Crossing the spread means that sending a market order that will get the other side. Okay? And couple of things I want to mention. I think many companies have the data, whether it's a buy order or sell order. In some cases, you don't have that information. Okay? In some cases, what you have is just a simple, if you look at the data that you download from Words, the crisp data, it doesn't have that information. What you have is that, sorry, trade and quote data doesn't have that information. What you have is just, you have to guess whether it's a buyer initiated call or seller initiated call. Okay? So essentially, I think the way they look at this is that if the actual executed price is closer to bid side or ask side, I think depending upon where it falls, you classify it as a buyer initiated or seller initiated. Okay? So you can see that these are the frequencies in which things are happening. Ultra high frequency, I think you'll see that there is a lot of latency issues. High frequency data, I think that's where we talk about optimal execution. Daily data is sort of gives you overall trading strategies, what you want to do for next day. Okay? So much of it is going to be decided, beforehand, but you also have to monitor the order book to see how the changes in order book can be taken into account. Okay? So a couple of things I want to mention when it comes to order book, people look at the following. Okay? So you have this mid price, which is supposed to be bid plus ask divided by 2. Okay? So this mid price can be traced over time, as you see. So that sort of tells you where the market is going. And so you look at this, I'm going to write it as some sort of average T, and then they look at trace P bar T, okay, over time. They also look at the volume on both sides. Okay? So it sort of gives you market imbalance, in the sense that are there more buyers than sellers. So it gives you that information. It's also look at the imbalance in the order book. Imbalance in the order book. So when I say imbalance, it could be the arrival rate on both sides, how it changes. It also means the volume of changes that could occur. Okay? So lots of issues that people look at. And for instance, if you look at Citigroup data, I think this is for one particular day, June 26, 2008, you can see that Citigroup price changed 4,469 times. So not 12,499 times, which means that the prices are changing constantly, But most of the changes are within a dime. It's not going to change that far, but it keep changing. Okay? So observation point to the relevance of asymptotic, because all this, lots of changes occur, but on the average, they fluctuate around certain point. Okay? So most of the modeling that you are going to see are going to be on limit order book as a system of queues. Okay? Queues means that people come on the buy side, depending upon which position they come, they wait around, right? Similarly, on the sell side, queues are coming, and how these two queues are going to interact, that seems to be the way people model this stuff. Okay? So we talked about level 1 data. Level 1 data gives you only the best bid and best ask. Okay? There is also level 2 data. In level 2 data, mostly people look at the first 5 positions on both sides. Okay? And with the level 3 data, you can look at all positions. You'll also get information on buy side and sell side information. Okay? So let me show you. I think currently we are working on level 3 data. So before I get into this modeling aspect of it, I think I'm just going to leave some of these things out because too much to cover in a class. So the paper to read is, as far as order book modeling is concerned, is by Kant et al., Ramakant. Okay. I think it came in operations research. Okay. So if you look at that paper, most of the calculations center around, the arrival rates of supply and demand and the imbalance between the two. Those are the two main things that go into the calculation. Okay. So before I get to this, I want to show you the level 3 data that we have, and let me I think I'm going to I need to let me look at this one here. So this is the kind of information that we have, and I'll show you the actual data in a minute. Okay. So what we did was we have data from 4 exchanges, J, K, Q, and Z. I'll explain what those 4 exchanges are. So we have some sort of timestamp. We also have, whether the submission of limit order on the buy side, submission of limit order on the sell side, and we also know the execution of a hidden order. Okay, there are some orders which are hidden. You don't see it until it gets executed. Then the full execution of a limit order. Sometimes if you put it 200 units, not all of them are going to be bought or sold at the same time. You have to do it in parcels. You go 100 and so on. Partial execution, full cancellation, and partial cancellation. Okay. And we also have the interesting information, that is that whether it's a buy side or sell side information. Okay? Whether it's a buy order or a sell order, which is not usually given in the usual data. And we have the price data, and then we also give you the size of the limit order and the depth of shares in the order and so on. Okay? So I think we took this data and did some processing of it, and I want to show you an upcoming presentation that I would be making. So I thought that might be more relevant for this discussion here. So I'm trying to see how to get this one. So let me also show you the actual data, how it looks. So essentially we took all these 4 exchanges, merged them together, and we are going to call it a superbook. So this is how it looks. Okay? So you can see that the exchanges are given here, and this is the event. It's a buy event or a sell event, and whether it's a buy side or sell side. And we are looking at Cisco here, and that is the order ID. The key part of it is the order ID information that we have. We can take the first order ID that you have, 351885, and trace it on the entire day to see whether that particular order got executed or cancelled or it got partially executed, or all kinds of information we can get. And we have the price, and we have the size. We also have the on the depth. On depth means that how far it is in the book, and then we have the relative price. We constructed the order book data after that. Okay, so at any point in time, we know how many orders are on both sides of the equation, buy side and sell side, and we wanted to see if there is any interaction between how the interaction between the two can be modeled. Okay, so this is what we have. I have to open my email account to get this one. I didn't put it here. Where is that one? So this is so we have this empirical issues with level 3 data. So the markets are changing, and there are fast, fragmented, complex, and so on. But I want to get to the main part of it here. Okay. So this is the actual data that we mentioned here. So these are the different symbols. I think you can see that there is a timestamp there, and then the order ID, and that order ID clearly shows that what happened to the order, so we can keep track of that order. The main problem with this is that once the order leaves the order book, the same order number can be given to a different incoming order, so you have to keep track of all that stuff. So usual data handling concerns, because these are all irregularly spaced, and the main concern that is unique to level 3 data is that all the other concerns are for any level 1 or level 2 data. Unique concern is that order numbers can be reassigned, so you need to be careful about it. So this is the analysis we want to do. What is the optimal time unit for aggregation, and how do you study the dynamics? And here we focusing mainly on this multiple markets. I want to see the linkages. Okay, what I mean by linkage is that in the algorithmic trading, the orders get submitted to multiple exchanges, right? And as soon as one order gets executed, all the other things get cancelled right away. Okay, so we wanted to infer whether there are any clusters of orders that come to the market. Okay. So with no proper ID that you can link these things, the way we are going to group them is that any group of orders that come within 50 milliseconds, we are going to call it as clustered orders. And we trace those clustered orders over time to see if anything happens to one order, what do they do with the others? And most of the time, the other orders don't get revised. They get cancelled. So they are constantly looking at the market to see if there is any potential. Okay, so there is all kinds of models people have looked at here, and many of them are pretty approximate. I think one of the models is given by Sheikh, as the Ox process models being looked at. So let me get to the empirical results here. Okay, and remember we talked about the fee and rebate structure. And this was a structure for January 2011. You can see in NASDAQ, I think, if you remove an order, you get a discount. And removing an order means that, you come and leave. And here you can see posting visible limit order, you get a discount here. So I think, these are the cost structure that people have. So I think as Max was mentioning, people want to maximize not only their liquidity, they also want to maximize their cost of execution. So wherever they are going to get rebates, that's where they are going to go. Okay, so these are simple thing I want to briefly mention here. So in terms of limit orders, I think for Cisco, you can see that NASDAQ is still the major player here, and there are some flows coming from BATS and others. In terms of number of cancelled orders, you can see less number of orders are cancelled in NASDAQ. Okay? So which means that NASDAQ may provide better liquidity. That's the reason why people are sticking to it. Okay? And then we wanted to study the source of cancellation. So there is this concept of fleeting orders versus non-fleeting orders. Okay? Fleeting orders are orders that stay in the book for less than 5 milliseconds or something like that. Okay? So which means that these orders are come in and go just to test out the market. So we wanted to, that creates a lot of noise, so we had to remove that data. Then we wanted to see if if we can model it better. Okay? So the way we clustered is that they should be on the same side of the book, right? Buy side or sell side. Should be same size and price but different venues. And submissions, executions or cancellations occur within 50 milliseconds. That's how we defined it. Okay? Since we don't have who the trader is, we can't make that any connection between them. Okay? So this is how the analysis works. You can see roughly 12% of the submitted limit orders belong to cluster. Okay? I think that number seems to be on the low side. I do expect more orders should be coming from traders, but this 12% means that these are 12% of the traders are submitting orders to multiple venues. That's what it means. Okay? And roughly buy and sell sides are even. Sizes are mostly less than 300 units. That means that they keep it in small size. And you can see these are the various combinations. Z is supposed to be BATS, and then you can see that 23.2% look at ZQ combination, 10.8 look at ZK combination, and so on. So the main idea here is that Z is supposed to be the BATS exchange that is always in the mix of combination strategy, clustered strategies. Okay? And we also looked at how long these clusters stay. You can see that with a small millisecond, the 16% stay in say almost close to 0 milliseconds. They take it out, 11% on the 10,000 milliseconds, and so on. Okay? This is a lifetime of clusters. Okay? And this is the cluster versus non-cluster orders. You can see what is the median time they stay in clusters. You can see clustered orders generally tend to stay less time in the and I think our goal was to see if clustered orders give them better price. Are they submitting them for the price information, or are they submitting them just to get liquidity? So when we looked at it, I think there is some price advantage that you see, and so it's not clear. I think this is analysis that we are currently working on. Okay? So I think we did some logistic regression and so on. We'll comment on it next time. So I'll try to post this also. I'm still working on one other slide. As soon as it's ready, I'll post it on the coursework. You can take a look at it. Okay? So I think on Wednesday's lack of time, I would post all the notes, but I'll give you brief summary of execution strategies. Okay? So in order to understand this execution strategy, there are 2 or 3 papers that you need to read. One is the paper by Omgren and Chris paper, which is very easy to read. And the second paper is on market impact models. And I'll post there's lots of references for it. I'll try to post an appropriate paper for that. So if you can read through those 2 papers, I think you can pretty much follow what's happening in the field. Okay? I'll stop here. If any questions, just let me know.